What Einstein once said, that the most incomprehensible thing about the universe is that it's comprehensible. And that's amazing, that's short lifespan creatures living on one small planet can actually work out what the universe is doing, where it came from, where it's going. At least we think we can, and let's hope we're right, and that science is working properly.
John Gribbin is an astrophysicist who worked at the Institute of Astronomy in Cambridge with Fred Hoyle, and he is now visiting fellow in astronomy at the University of Sussex. He's best known, though, for probably being the most prolific writer of popular science in the country. I counted 103 books on Wikipedia, and I suspect that there are many more. His books include In Search of Schrodinger's Cat, Schrodinger's Kittens, The Scientists, and more recently, 9 Musings on Time and 10 Tantalizing Truths. He also writes science fiction. He's a fellow of the Royal Society of Literature, and he's been described as one of the best science writers around. So, John Gribbin, thank you for joining me today.
It's an impressive list of things.
It's an impressive career, I would say. Tell me, I mean, it is astonishing, isn't it? 103 books, probably many more than that. Do you know any books?
A few more.
How many books have you written? Do you know?
I last counted up 130. Somebody asked me, but I don't sort of tick them off as I go along.
How do you do it?
Well, I don't do much else. I mean, that's one reason. Having my wife will tell you I'm very bad about helping around the house.
Well,
But
she helps you for the writing, doesn't she? Because I've
she
seen her
does,
name.
yes. She's invaluable because she's got a background in psychology and teaching, so she knows a lot more than me about communicating, especially when we do things for very young readers.
So how do you actually go about the writing process? I mean, do you have a plan? Do you get up at 6 o'clock in the morning and write for 4 hours and then have an afternoon walk, or what's your how do you get into a routine of writing many books?
Well, fundamentally, you're right. I mean, over the course of the long career which you mentioned, that was more or less the way I worked. I would get up and write, have a cup of coffee, write, then have breakfast, and do something to refresh the mind, and then do a bit more writing, and then not much writing in the afternoon. I would later in the day, I would do what writers laughingly call research. As I used to be a real scientist, I think that's a bit of a joke, but I would prepare for the next day and so on. Latterly, I've slowed right down and I just fit in around what else is going on. And I've been writing a series of rather short books, the one you mentioned, Nine Musings on Time, which are easier to write in that sense because they're more compartmentalized.
Yes, I was looking at the 6 Impossible Things, 7 Pillars of Science, taken from, I think,
Yeah.
There, 8 Improbable Possibilities, 9 Musings on Time, 10 Tantalizing Truths, and what I'm
Yeah.
expecting next, I'm hoping for,
Now,
is 11 Laws for Learning.
well, the next one is actually this one about against the odds about women scientists, and there are actually 12 of them. So we've skipped 11, but that's the latest
11
one.
Laws for Learning. I got that from.
There probably will be something.
All right, but when you come to write, you have been spoken of as one of the best writers. I mean, you're now a member of the Royal Society of Literature. What what are your rules for writing well? How do you get that balance?
Well, I stumbled on it by accident. I used to be much more of a hack writer. I worked on science magazines and sort of wrote copy to order. And I wrote books which were really like a series of science articles stuck together. And when I came to write In Search of Schrodinger's Cat, I wanted to know about quantum physics, and there was no book. So I eventually ended up writing the book that I wanted to read. And so I wrote in what writers would call my own voice. and I wrote the book that I wanted to read, and I got a response from readers that it was like talking to somebody, that it was literally like a voice, that it wasn't like words down on paper. They could imagine me talking to them, and that was sort of the trigger which made me realize that. And very often I do either literally read bits out loud to myself, or I imagine them in my head, either in my voice or in the voice of somebody famous, so that I can get a flow for the words instead of it just being a load of sentences on paper.
I mean, that's something which does come over because it has a very conversational style.
That's a
So
good word. Yeah.
not here, for example, in the preface of Musing on the Muses, I've been fascinated by time travel since I started reading. And then you say, and I was going to say, since I started reading science fiction. That's very conversational in its approach. How do you marry together the technical demands of your subject, because you're dealing with some quite complex issues, with in a conversational way?
The key is to know what you're talking about. It sounds easy, but that's where the research comes in. For each bit, and ideally for the whole book, I need to spend a lot of time preparing the ground, and making sure that I know what's coming next, so that it then does flow as if I've got it all in my head, which I have for a day or a week or a month or whatever it is. But now, I mean, if I look back at, well, In Search of Schrodinger's Cat, or Deep Simplicity, or one of those, I think, well, how did I know all that? And the answer is it's like cramming for an exam. You know it all for a short time, and then it's gone. But that's you really have to know more than you're writing about. That's the secret. It's not just what you're writing about. There's the background, the bits that don't get in the book. They're just as important to the narrative.
But you have to somehow know to select those out and
Yeah,
keep them out
that's
of the book.
yes, and that's where the other thing that I learned, not immediately but eventually, was that you have to talk to other people, show things to other people. I was very nervous when I started writing books. I'd sort of keep it to myself, and then it'd get out, and then some reviewer would point out a flaw in it, and I think, oh, I wish I'd thought of that. And then I learned that you have to actually take either the whole book or chapters and show them to people at the early stage, and then they will say this doesn't read very well, or can't you express this in a better way, and then the final version is that much better. So don't be shy. Someone's going to read it eventually, so why not now?
So, what would be your main advice that you would give to new writers, people who want to follow your pathway, your career?
Well, today, obviously, the way to start is by blogging. I mean, it's not something that I do, except in a very desultory way. But in my day, we didn't have any of that. So if you start by having something that establishes you as a presence, in some sense, and you get some followers, then you're in a position to show what you've got to conventional publishers, for want of a better word, and get them to take you seriously. And I think you still have to, it's very unlikely that you'll be able to jump in and write a book. But you have to find an outlet for, still in the print media or online media, so that you can write article length things and build up a reputation and experience, and do it that way. You have to start from the ground up, and in my day that meant newspapers. Now I think it means the internet.
Did you find difficulty getting published to begin with?
In terms of books, some and some. I was, by the time I started writing books, I was already working for the science magazine Nature, and writing for people like that, and for the Times. So as I say, I had what you might call a portfolio of stuff, and also Nature at that time was published by Macmillan, which also published Macmillan Books. And so I was able to go upstairs and say, I've got a great idea for a book, instead of having to go in the door as a complete unknown. They knew I was somebody sort of in-house. So that made it a bit easier. But you mentioned Schrodinger's Cat, which is by far my most well-known book. 8 publishers turned it down.
Yeah.
So they said nobody's interested in quantum physics. This was 40 years ago, and there were no books on quantum physics. Now there's a whole shelf of them if you go
Yeah.
into a bookstore.
I've got piles in my study.
So I was very lucky there because I was the first, and that there was an interest, then it became known as the book to go to simply by being first. And somebody once said you got to either be best or be first, and that's what I did.
So if you get in there quick, you can get a bestseller. But you have
Yeah,
to find the niche, don't you? That's the thing.
that's it.
But you've got in with lots and lots of things. I mean, I just went to my own bookshelves and I had a very, very quick survey. And I found I've got a number of books by John Gribbin on there already. So I mean, I just picked out. You've had some spin-offs. We've got Computing with Quantum Cats. I
Yeah.
found on there. I've got Erwin Schrödinger, and there are other ones too. It's just amazing the topics that which you
Well,
picked up on.
there's the quantum physics is a bit of a niche, but the spread of topics is because of the thing that I told you about Schrodinger's cat. I find a subject that I'm interested in, but I don't know anything about. Then I go and find out all about it, and then I write the book that I would like someone else to have written first, so that I didn't have to do all the hard work. And that's where the biographies come from, and the quantum computing recently. Yeah.
That approach reminds me of my old professor because I did quantum physics as my doctorate with David Bohm,
Mm.
and he was saying that he first got into quantum mechanics simply because he felt he needed to write a book about it, and it's about like I think it was Henry Ford's advice: if you want to learn a subject, write a book about it. And Bohm took that quite seriously. He wrote his book on quantum theory, and in a way which many people found quite eye-opening. Yeah,
Yeah, there is though the other side. There is. I still do what I call that the hack writing. You know, not meaning that as a term of abuse. Professional, like being a bricklayer. I mean, sometimes people do ask me to write a book about something topical or whatever, and I obviously I can use my journalistic background to do that. So there's two kinds of books. There's the ones I write to please myself, and the ones I write because there is a demand for it in the sense that someone's willing to give me money for it, which is obviously an incentive.
yeah. Well, you obviously don't just write for money because clearly no one would write that amount of books if they weren't passionately involved or interested in what they were
No,
doing.
no, it's I think it's like in Lorelei Lee in the film uh, says about beauty being a man being rich. Um, isn't necessary, but it sure helps if you're choosing a husband. And I mean, if I want to write a book, if someone will offer me money, it sure helps. But I do still write things without an advance. I mean, that was the thing about writing Schrodinger's cat. It was the time I'd reached in my career as a journalist where I had enough savings to be able to spend 6 months writing something that I hadn't got paid in advance for. And then best part of another year having it not sold to any publisher. So that's very important. But after that, that sort of opened the door, and I've never had to. I've sometimes done it from choice, but I've never had to do it that way.
It's kind of the J.K. Rowling effect, isn't it? You take your book around to half a dozen publishers, or in her case, I think over 100 publishers.
Yeah.
They all turn it down because it seems that they haven't got a clue as to what would really sell and what would take off. It's quite surprising.
It's the yeah it's the Me Too thing. They a publishing phenomenon like Stephen Hawking's book. You know, once that becomes a surprise bestseller, all the publishers were rushing around saying, "We want a science book. We want a science book." And for a time, you know, you could sort of write your own check almost if you were a scientist who had any kind of ability to write a book. And then it all died away a bit, and now we're back to what passes for normal.
Yeah. I get the feeling that most people who write books couldn't possibly make a living from them because
Oh,
it,
yeah, you absolutely not. The figures you get every year from the public lending rights, you know, are a good indication of how little you can earn from writing science books in particular. But yeah, in general, it's very hard to make a living out of it.
Would you recommend someone getting an agent if they wanted to be a writer, or would you not bother with that kind of route?
I would definitely recommend getting an agent. That can be as hard as finding a publisher. Once you've got an agent, you then have got something of an open door to talk to publishers. And the other thing that I would recommend is the Society of Authors, which if you have to have written a book and had an offer. If someone has offered a prospective writer a contract for a book, you can then join the Society of Authors and they will vet the contract and act in some ways as an agent to give you advice. And for science people wanting to literally follow in my footsteps, as the Association of British Science Writers, which you can join and which will give advice and point you in the right direction. But yeah, if you can get an agent, absolutely essential. But if you can't, just keep trying anyway.
Were you pleased to be elected a fellow of the Royal Society of Literature?
Yes, it's I think it's a bit of a token scientist thing. I mean, I'm not putting it down. It's a very worthwhile thing to be.
Yeah.
But I think they felt that they were lacking in science people, and that they should try and encourage a few to join in and get involved in their work, which is good. You know, that's entirely a good thing.
Yeah.
So yes, it's very flattering to be able to stick some letters after your name if you want to.
I was astonished at the range of books that you've looked at. You've done
Mm,
children's books and you've done biographies in particular,
yeah,
mostly scientists. Though you have picked out biographies of some unusual people like Buddy Holly, and
yeah,
but things like Einstein and Darwin and Schrödinger, as I
yeah.
mentioned, James Lovelock, people like that. Who was your favorite character, and how did you pick a subject? I mean, is it just something you're drawn to?
Yeah, out of those group of people, out of all of them, I mean, in scientific terms, I think Feynman, because of his unique contributions to science. But as a person, of those, Jim Lovelock, who I knew quite well, so I didn't really know many of the others. But Jim, I think, was the cleverest person I actually knew. You know, maybe not quite Feynman, but he knew a lot of stuff about a lot of things, and was a very pleasant person as well, generous and thoughtful in the deepest sense. It was slightly difficult because there was something that we were encouraged to do, and it's the only one we did of a living person. He was alive at the time, and it was very difficult to avoid veering into hagiography and saying nice things about him because he didn't want to offend him. Although he was the last person who would have been offended by you saying it. He was uh, honest and open to the point of being ridiculous. You know, he had no barriers about telling the truth, and so he didn't have any barriers about us telling the truth. The thing we missed out on is that at the time he wouldn't reveal all the secrets about some of the work he'd done for the Secret Service. And he's got a more recent biographer, and he was obviously in his last couple of years of life when he was talking to him, and he said, "Well, I might as well spill the beans now." And so there's if you take our biography and the new biography and put them together, you get the whole story.
Yeah, so kicking yourself that you didn't get
Well, we couldn't wait till he was dead. You know,
you did have an early career as a student of Fred Hoyle. Were you ever tempted to write a biography of Fred?
I was tempted, but one of my exact contemporaries at the Institute of Astronomy beat me to it. Simon Mitten. He wrote a very good biography of Hoyle, so there was no point in us covering the same ground. I like to be thought of as working with Hoyle. I mean, it was a very distant relationship. You know, he was the professor and head of the unit, and I was the youngest student. But yes, you know, I talked to him about my work, and you know, chatted about life over coffee and things like that.
How did you get on with him? Was he an easy person to
He was
speak
quite
to?
quite difficult. He was is the proverbial person who's actually very shy. but protects it by being very blunt and difficult to approach at first. He was also having a lot of trouble at the time, although I didn't know because I was too junior, with getting the funding for the institute sorted out and having disagreements with the University of Cambridge and stuff which boiled up a few years later and led to him leaving. So he had a lot going on, which didn't make him easy to approach, but he was very good about when the institute started, he had a party for all the new people, including the students and so on. And he got on with the computer staff and everybody. But I don't have any sort of personal direct reminiscence, except the one where I was reading his ideas about time travel, which he put in the book October the 1st is Too Late, and he says in the front or the back of the book, I can't remember which, that this is a fiction, but the ideas about time are intended to be taken seriously. And I did once go up to him and say, I like the book, and I'm very interested in these ideas about time travel, and are you meaning them to be taken seriously? And basically he said yes, and that was more or less the end of the conversation. But saying, you idiot, why would I have said it was to be taken seriously if it wasn't? But it was okay.
I was talking to Jim Peebles a week or so ago, who got the Nobel Prize for the cosmic background radiation and the Big Bang proponent, and he said he had many conversations with Fred Hoyle about Fred Hoyle's steady state view, the opposite view of the Big Bang, and he sort of said that Hoyle was a bit of a tragic figure in his view, that he never came round to viewing the evidence clearly or enough. He always held on to his own views in a way which was rather dogged and seemed to finish in a kind of a tragic kind of way.
That's true in a way, but one thing he did say to me was that it's important to, what he put it, compartmentalize your work. And although he is known, as you say, as a tragic figure who never accepted the Big Bang, he was also one of the prime authors in the work on the nucleosynthesis and the formation of the elements, which is directly relevant to the Big Bang. And he could do that work about making elements in stars and work on the making of elements in the Big Bang, which is sometimes forgotten, that he was one of the team that explained how the very lightest elements are made in the Big Bang, because you can't make them in stars. And he could sort of take a problem and sort of say, if there was a Big Bang, then this would be the consequences, and I don't necessarily think there was one, but and work it out that way. And also the steady state theory is sometimes maligned. I mean, I should put in a word for Fred.
Yeah.
The what we now have, one of the best ideas we have is called continual inflation, and it says that there is a very rapid expansion going on, and that this is one bubble inside a bigger universe or multiverse or whatever you call it, where there are other bubbles of expansion going on. And if you were to combine aspects of the steady state theory and aspects of the Big Bang theory, you could come up with something very much like what is now called the Standard Model. So I think there's also prejudice on the other side. People say, well, it's completely wrong. We won't pay any attention to it at all. But that's the way science goes.
You also are a writer of science fiction as much as science fact, and you've included stories in Analog and places like that. Is writing fiction a different process for you, or is it exactly the same thing?
It's very similar, but what happened is that the fiction improved my non-fiction writing. I've been a science fiction fan since I was tiny, 8, 10, and I always had an ambition to write that kind of science, the sort of hard science fiction, Arthur Clarke and Isaac Asimov type science fiction, and I got around to doing it and writing for Analog first and then books. And my agent was very downbeat about it, because he says you're not going to make money writing this. You should be spending your time doing something more worthwhile in terms of finance. But what I found was that by writing fiction, I learned about narrative and voice, things we were talking about earlier. And that had a really noticeable effect. Only noticeable with hindsight on my non-fiction writing, especially because I did some collaborations with some really, really good writers, Douglas Orgill and David Compton, and they would teach me how to present stuff, and I would teach them. I remember Douglas, one time we were working together and I got a phone call from him, and he said, "We've got this character who's a scientist, and he's in this situation, and now I'm not quite sure how he's going to react." So I said, "Well, how would you react?" And he said, "Oh, I'd do so and so." And I say, "Scientists are human beings, do the same as you would." And so that helped him, and then what he told me helped me. And I remember I wrote a descriptive bit in one of our books about things going on in Vatican City. I'd been there for a scientific conference, so I knew my way around, and I wrote all this, and loads of people afterwards were saying, "Oh, that was a really good passage that Douglas wrote about the Vatican." I said, "Me, wasn't Douglas?" Yeah.
I'm reminded of something that I heard Isaac Asimov said, that when he first started writing fiction, he had to unlearn all the things which he'd learned about writing science papers and
Yeah.
science like thesis and those kind of things, which were rather stilted and rather straight. And he had to learn to forget to do all of that and write in a completely different style. I don't.
That's very true. I've heard that story before, but my background on nature prepared me for that in a way, because in the days of John Maddox as editor of Nature, he was very keen on getting scientists to write in an approachable way. And one of my jobs as a junior editor on the magazine was to take jargon-filled science papers and turn them into English, for want of a better word. And so that's exactly the process that Asimov was talking about. So that helped enormously. I mean, Maddox was a great influence in that sense. He was very much one of those people who don't do what I do what I say. He would tell you all the ways to do something and get it right, and then he'd do completely different things himself. But if you listen to what he was saying and his experience as being a journalist on The Guardian and places like that, then it was very useful.
So if you want to be a good writer, write in an easy conversational style about hard and difficult topics, or don't flinch from the hard and difficult
Well,
topics.
make sure you understand it first. Do
Yeah.
your research. That's the other thing.
I
Yeah.
suppose if you don't understand it, you can't translate it into an easy style, because if you can't explain it to other people, then it's because you don't understand it yourself.
That's a good point. Yeah. Yeah.
So can I come to your most famous book, which is, of course, In Search of Schrodinger's Cat, where you made quantum mechanics accessible to millions of people who had only just heard of this bizarre science. What's the heart of the matter?
I think entanglement, the idea that you can have two, for want of a better word, particles, so that's not a good term, and they interact here and then they fly apart. And because they've interacted, there's in some connection between them, what Einstein called spooky action at a distance. And experiments have now proved that if you tweak particle A, particle B responds, not in a way which involves transmission of information, but that there is some kind of connection between all quantum entities, which is a term I like to use. And so that, in a sense, everything's connected to everything else, which opens the doors to a lot of very strange hippy dippy ideas, as Feynman also put it. But there is now not just lab-based evidence, but practical work's being done with beaming things from space down to Earth, and providing a basis for what could eventually be secure communications, and involving quantum processes. That's the hardest thing to get across.
I mean,
Um,
that's been proved experimentally now.
yeah.
And I remember Alain Aspect did an experiment on demonstrating entanglement. I think he got a Nobel Prize for that as well.
That was actually the key to me writing In Search of Schrodinger's Cat. It was that
But
experiment which I had to write up for New Scientist. So I had to find out about that, and then I would say, well, where do you find out about quantum physics? Who's written a popular book? And there wasn't one, so I did it. But it was specifically that experiment that sort of lit the fuse.
um, in a follow-up book that you've done, which is Schrodinger's Kittens, you talk about some of these kind of spin-offs now of the theory to real-world computing, and we're seeing that in a big way
Yeah.
with certainly quantum computers taking off. Have you
Yes,
any
it's
comment
something.
on what we can expect with that?
Well, it's moving so fast. There's a group at the University of Sussex where I hang out some of the time, and they're very heavily involved. They've now got a business, and they're working on developing a working quantum computer. I mean, it's at the moment they're talking about, having a machine the size of a tennis court or something, but that not so long ago, when I was at the Institute of Astronomy, I worked part-time in the computer room there as a computer operator, and that was about the size of a tennis court. I don't know how quickly it's going to happen, but it is going to happen very quickly, and it will change everything, I think. Yeah.
And any particular area that you think is going to affect? I mean, there's people talk about cryptography being broken and financial institutions having difficulties, that kind of thing. Any?
Yes, that it's cryptography is the big one, because that's where the military are involved, and so that's where the money is involved. So I think that's where progress will be made most rapidly. Whether we'll be told all about the progress, I don't know. And then, as you say, if you you can't predict stock markets, but you can get close to analyzing trends and things, then they would be very interested as well.
I
But
believe
but
China.
any big problem, one that's also something I've written a lot about, climate change. I mean, if you can simulate what's happening to the weather and the climate more effectively, that's going to be very useful if anybody acts on it. That's another matter.
In the book, the most recent book of yours, which I've got, no, I know you've done a more recent one than this, and even one which you've just shown me, Nine Musings on Time, science fiction, science fact, and the truth about time travel, which is a very well written book. I mean, I found it a fascinating thing, but it does have issues on about time travel. And you mentioned this with Hoyle. Do you believe that time travel is possible? And under what circumstances would it be possible if it
Well,
was?
I always have trouble with this word belief when it comes to science, because the whole point about science is you don't believe anything. As I was once on a panel discussion, and there was a Malcolm Muggeridge, who is a sort of spokesman for the Catholic view at the time, and he said something along these lines to me, and I said, no, we scientists don't believe anything. You're the ones who believe things without evidence. There's nothing in the laws of physics which prevent time travel, as at present understood. So the laws of physics, particularly being general theory of relativity, which has scope for, in the jargon, closed time-like loops, which means there's a way to travel through a path in space-time and get back to where you started. So obviously at some point you've gone backwards in time, and that's not forbidden. And there's a quip in science that anything that's not forbidden is compulsory. So, then it ought to be possible. And there are the simplest way, mathematically, not in practical engineering terms, is to have a wormhole, which is part of the science fiction jargon, but is a real thing. Well, potentially a real thing, where you have basically what amounts to two black holes in different places and different times, or even next door to each other in the same place but at different times, and you jump in one and you come out the other one. The trouble is holding the door open, as it were. You need very powerful energy and forces to do that. But again, nothing that is impossible according to physics.
I mean, this is basically a theoretical construction based upon the solution of Einstein's field equations, isn't it? I
Yes,
think.
well, it's a situation which has often happened in science where the physics is there and the physicists say, well, we've solved the equations. Now you engineers can go away and build one. So it's down to the engineers now. But the engineering involved, you'd need something like a, 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 two black holes, basically, which you'd have to make in the first place. And then you take one of them and tow it off on a long journey. They're close to the speed of light, where relativistic time dilation would come into effect and time would run slower. Then you bring it back to where you started, and you end up with one end of the wormhole being in 1 year and the other end being in another year. And so you could go round and round as often as you liked. But one thing you can't do, what the laws of physics do forbid, is having a time machine that will take you back before it was built. So we can't build a time machine now and go back to the Battle of Hastings, although I do say we can in one of my books. But you can build a time machine now, and then in the future, people could come back to here. And this is one answer to Hawking's famous so-called paradox: is if time travel is possible, why haven't they come to see us? And the answer is they haven't built it yet. And the day that the time machine is built, we will be flooded with visitors from the future.
Of course, that day might cause a bit of a problem with the time warping process, because if you think about it, I suspect that if someone could build such a time portal in the future, it might explain how you can't get back here and how you can't kill your grandfather. And you can't therefore introduce a paradox. But paradoxes could be introduced after that time, and that might signal the end of the universe for all we know. I don't know.
Yeah, the paradoxes are one of the things that features in the book is how you resolve the paradoxes, and there are several possibilities. The two obvious ones: one is that the time is not flexible, and that it exists as a fixed whole. So, if you try to go back and kill your grandfather, something will happen to stop you doing it, and that's featured in a lot of science fiction stories. And the one that they almost did but didn't quite do properly in the Back to the Future series is the idea of parallel universes, or the multiverse, where you go back and kill your grandfather, but that's in the universe next door. So that universe then develops in a different way, and in your universe, he's still alive. So there are ways around the paradoxes, and I go into them in some detail at the end of the book.
Do you think there is such a thing as a multiverse in reality, or is it just again a science fiction?
It's one of those things, as somebody said, I think it's real on Mondays, Wednesdays, and Fridays, and on Tuesdays, Thursdays, and Saturdays I don't, and Sunday I rest. And I don't know, but it's very tempting, and I'm
Because
intrigued by this idea that every so-called fiction could be real. This is David Deutsch at the University of Oxford. It's no idiot who suggested this. He's saying that these things could you know, all be completely real because they're possible. Whereas Harry Potter wouldn't be real because it doesn't obey the laws of physics. But there's nothing in Jane Austen's novels which doesn't obey the laws of physics, so they could be real.
you could, of course, say that you don't believe it in this universe, but you do believe it in
That's
another universe.
yeah, that's another way of
More
thinking about it.
paradoxical,
Yeah,
maybe. So,
no,
but I think the real thing about multiverses is you don't seem to be able to go from one to the other, or there doesn't need to be any mechanism by which to do so, which means that you'll be forever separated and you'll never even know if they exist or not. Then
that's the flaw. Yeah, there's no way to communicate across the timelines, but unless you've got a specially adapted DeLorean flying car. But that yeah, it's frustrating in that sense. But the person who said that the wave function doesn't collapse was Schrodinger. I mean, he was very upset about the whole idea of human consciousness having an effect on quantum physics, and he pointed out way back in about 1951 that there's nothing which says that the wave function should collapse, and it can all possibilities can coexist all the time.
Yeah.
Insofar as all the time means anything.
No. One of the other things that you've spoken about, the existence of life or the non-existence of life in other parts of the Milky Way and our galaxy. Would you say you still hold to that view that we're probably the only intelligent life form, at least in our local district?
Yes, I would defining intelligence as being a technological spacefaring civilization, with the caveat that, by some criteria, whales are intelligent, and you can imagine similar situations. But I think that the particular circumstances that have led to the rise of, if that's the right word, of human civilization are probably unique in the Milky Way. Yeah.
And what about beyond the Milky Way, though? Other galaxies?
Well, infinity is very big, so I would not rule out the possibility of something somewhere in a galaxy far, far away.
It's life, but not as we know it,
Yeah.
Jim. That kind of thing, I suspect so. One thing which you did when you were an astrophysicist was something called the Jupiter effect,
Oh,
which you probably want to forget about. Is that right?
yeah. That was that was sort of a youthful folly, and that
In
was
what way was it useful for you?
yeah. Well, the it was just after I finished my PhD, and I wrote a little tiny scientific, what they call a letter, not really
Yeah.
a scientific paper, in the journal Science, because there'd been a big paper saying that there was a correlation between earthquake activity and the rotation of the Earth, and there was also a correlation between solar activity, and that this must be a coincidence because there's no way that the sun could affect earthquakes. And so I said, well, actually, it can, because the sun affects the atmosphere, which changes the spin rate of the Earth, and that could trigger earthquakes. And it was, this big. And an American publisher got hold of me and said, you could make a best-selling book out of this, write a book about earthquakes and disasters and mention California. And so I said, well, I'm not sure, but I'll think about it a bit. And then I got a friend of mine who's a geophysicist, and said, look, would this work? And he said, well, we could make a scenario. And he said, yes. So we worked out a synopsis and sent it back to this publisher. And he said, oh, no, this is no good. It's too scientific. It's not enough doom and gloom and disaster. So he said, well, that's a shame. And so that was the point at which I went upstairs at Macmillan and said, look, we've got this half idea for a book, is it worth pursuing? And they said, yes. And so it's a book which is half quite sound about solar influences on weather, on the atmosphere, and how that affects the spin of the Earth, and how earthquakes work, and so on. All that stuff's pretty good. But we made the mistake of tying it to California and saying this could lead to a big destruction in California in, I don't know, the 1980s or something, and
Yeah.
it obviously didn't happen. But if it hadn't had that peg, it wouldn't have got published.
Yeah.
And if it hadn't been published, I might never have gone on to write other books. So I'm not ashamed of it. I don't regret doing it in that sense. But I do regret that a lot of people did pick it up and say it's the end of the world, it's a disaster, without reading it. This is what happens. You get people saying there's this book predicting that California is going to fall into the sea next week. I say, well, have you read the book? Well, no, so it got a lot of unfortunate publicity. But there you go. I was only 12 when I wrote it.
Well, there was a story in the Daily Mail, I think, only yesterday, saying that the Earth's rotation has speeded up yesterday, and
Yes.
it's the shortest day or something.
Yeah. Yeah,
Which,
it does happen, and there is some evidence that there are correlations with earthquake activity, though which way round it goes. When there's a lot of earthquake activity around the Pacific Rim, there are changes in the Earth's rotation, but they're tiny, milliseconds and so on.
Yeah. Um, the the biographies you wrote again. Can I ask if you could go back and talk to one particular scientist and spend some time with them, which one would you choose?
I mean, in history, going back forever.
Yeah, you could go back
Um,
to Aristotle, or you could go back to
no,
Einstein.
William Gilbert. I bet you've never heard of him. He was a
I've heard of Gilbert White. I haven't heard of
uh,
William. Tell me about
William
it.
Gilbert was his day job was a physician, and amongst other things, he was one of the physicians of Elizabeth I. But he was a natural philosopher. He was interested in magnetism, and he studied magnetism, and he worked out models of how the Earth's magnetic field was generated.
Huh?
And he wrote about it in a book which was the first clear exposition of the scientific method of how to actually do science instead of wandering about thinking beautiful thoughts about science.
I thought that
And
was Roger Bacon.
no, but Bacon never did it. He just thought beautiful thoughts. Gilbert was much better, and Galileo refers to Gilbert as an influence. So Gilbert influenced Galileo, Galileo influenced Newton, and the rest is history.
It's
And
interesting, I think.
what he wrote about magnetism and what he discovered was the story for 200 years. It was the 19th century before anybody really found an improvement on what he'd said,
Oh.
and nobody knows who he is.
No,
So,
no,
so that the other people you mentioned, yeah, it'd be nice to talk to them, but we already know a lot about them. It's more interesting to know about somebody who is unknown now, if you see what I mean.
the trouble is you can't easily write a biography of such a person because no one would buy it, would they?
No, that's the other problem. If you wanted to write a bestseller, you'd have to, yeah. Well, if Robert Hooke would be a good one for somebody who's people have heard of but not properly. We did half write a biography of Hooke.
I've got a big biography of his somewhere, Robert Hooke. I'm sure I've
Yeah.
picked one up in the second-hand bookshop.
No, we did a book that was sort of half Hooke and half Hawley, sort of as the two people who were in the shadow of Newton and don't get the credit they deserve,
Yes,
even
yeah,
though you've heard of them.
yeah. When you do write with another author, how do you
Yeah.
divide the book up? Do you say
Okay.
I'll do chapters 1, 3, 7, and 9, or do you just write bits and then compare them, or what?
The scientific biographies are very easy because that's exactly what we do. One person writes their biography and one person writes the science, and obviously you go to and fro between each other. The collaborations that are not biographies are much more complicated, and they vary. It depends on the person and the subject and what your mood is and how you're getting on with each other and all that sort of thing. But I've done ones where we almost not quite write alternate pages, but almost actually sitting down, like the way Lennon and McCartney used to write songs in the old days, sort of head to head with two word processors and writing more or less simultaneously. But the best way, I think, is to write different chapters, not necessarily alternating. But you might say, one person might do chapters 1 to 3, and the other will do 4, 5, and 6. But the key thing is to keep it moving between the two of you. Don't sort of write your bit and just sort of stick it together. They have to be dovetailed and cross-linked in various ways.
So that ultimately you can't easily tell who's written which bit, you mean?
That's the ideal. And the even better than that is when people get it wrong. Say, oh, well, obviously you wrote that bit. Say, no, it was him or her. Yeah.
That's what you don't want to hear when you've written a joint book.
Yeah.
Yeah. We're coming to the end of our time together, John, and we've covered quite a lot of ground, but I did want to ask you some more questions, well, just basically one question really about, as you look forward to the future, which problem in physics or science intrigues you the most? And if you could sort of wave a wand and say, I'd like to be able to solve that particular problem, Which would it be?
God, that's a bit of a stunner.
Could be is it dark matter? Does that what keeps you up at
Yeah,
or
well, not dark
consciousness?
matter, dark energy, that and the implications for the fate of the universe, and also that's something which we may very well have an answer to soon because of the Vera Rubin telescope that's just started working. So yeah, that's my roots are in cosmology, and that's really the one I'd like to see answered.
Has your work on cosmology and the bigger things of the universe influenced at all your understanding of human beings and how they should be or what we should do
I
and how we should?
Well, it does tend to make me think about how insignificant we are, and you know, my wife doesn't like it. She says if you look at the stars and think we're insignificant, you know, what's the point of it? You know, it all makes you feel very small and useless,
That's
and
like Pascal, who said the frightening, stars hem me in. He's just terrified by them.
yeah, I think she leans that way, but I have more the cliche sense of wonder, you know, that these things do exist. And what Einstein once said, that the most incomprehensible thing about the universe is that it's comprehensible, and that's amazing. You know, that's short lifespan creatures living on one small planet can actually work out what the universe is doing, where it came from, where it's going. Or at least we think we can, and let's hope we're right, and that the science is working properly.
Yeah. My final question to you, literally, is you've had an amazing career of writing kind of things, producing all manner of books and other things too. When you look back over your career, what are you most proud of? What stands out for you as the thing which you'd like to be most remembered for?
But the book I'm most proud of is Deep Simplicity, which is about complexity and chaos, and was the hardest one to write. That was really difficult to get my head around all those things, and to explain that in an intelligible way. I think it was much harder than quantum physics. So as
What's the central theme of that then? I have to confess I haven't seen that one, but I'll look it up.
it's Well, it's about how the simplest rules in physics lead to complexity and eventually to life. That's the sort of the blurb on it, and it involves chaos theory, complexity theory, and how living things work. It was very hard work to do, but it's not remembered by anybody.
Well, I will certainly make a point of looking it up. People will who listen to this will go and look it up as well.
Live in hopes.
Dr. John Gribben, thank you very much indeed for your time today and talking to me.
Thank you. It's been fun.